Hey everybody, this is Alex Merced, and you're listening to another episode of Select Star from Data Lake. And in this episode, we're going to continue on with our sort of exploration of Apache Iceberg. So in the last episode, we talked about what is an Apache Iceberg catalog. And again, the purpose of the catalog would be to direct any tooling to where the Iceberg metadata exists. And that's going to be our topic for today. What is the Apache Iceberg metadata and how is it structured and why is it structured this way? Okay, bottom line is this. It's the thing you want to kind of go into this thinking is that the structure of the metadata is that generally the information that you're always going to want to look at is generally going to be at the top of the metadata. And then basically the kind of information you don't necessarily need to read on every query is going to be further down sort of the metadata tree. The purpose being that way you're not reading metadata you do not need to read to improve the performance of queries. Okay, so that's the idea. The idea is to make the planning of a query as efficient as possible, which would result in the most efficient query possible. Okay, and that saves you time and money because the query is done quicker and using less computing power. So it saves you money in that regard as well. Okay, so what happens first is that at the top level, you have what's called the Metadata.json file. And the Metadata.json file essentially is created for every time the table changes. So the table gets created, the Metadata.json file, the first Metadata.json file is created. Then you add a record, another one gets created. Then you delete records, another one gets created. So essentially, every time the table changes, a new metadata.json file is created. This is the starting point. This is what the catalog points to. Okay, so that's kind of how an engine knows this is the current version of the table because the catalog points to that particular metadata.json file. Now, what do you find in this file? Like, what does the engine need here? Now, the couple things that the engine needs to know. An engine needs to know sort of what the schema of the table is. So in this file would have the schema, not only the current schema of the table, but previous schemas. So that way it's generally kind of in an array. So that way later on, as we get to individual files and groups of files, we can identify the schema those particular files were written with based on their sort of index in that array. Same thing with partitioning, okay? Basically, one cool thing about Apache Iceberg tables is you can update how the table's partitioned. So in that case, in this metadata.json file, there is the current partitioning scheme and then an array of all previous partitioning schemes. So again, each one now has an index in that array or an ID, which that can then be used throughout the rest of the metadata to say, okay, this data was written using this partitioning scheme. So partitioning scheme 0, partitioning scheme 1, partitioning scheme 2. Okay, and this just kind of allows engines to be able to understand sort of the context of data as it works its way through the tree. So that's essentially what the metadata.json does. It just tells us like, this is the table. This is the table schema. This is the table's partitioning. And then also an array of snapshots. Okay, so again, a snapshot is a picture of the table at a particular point in time. Think of it kind of like a git commit. So what will happen is that assuming that my query says nothing else, it's going to assume that I want to query the newest snapshot. I could specify a particular snapshot or a particular timestamp to query previous snapshots. That's referred to as time travel. But whatever snapshot I end up querying, it's going to look in that metadata.json, get the information for that snapshot and say, okay, here is the file that describes that snapshot, referred to as a manifest list. Okay, so you can think of anytime I say manifest list as the snapshot file. I will just probably refer to it as the snapshot file. So that way it gets less confusing when I talk about manifest later on. Okay, but each snapshot file, essentially what's going to have is the information for that particular snapshot, that particular point in time in the table's life. Okay, so it's going to basically say, hey, right now, at this point in time, we are adhering to this partitioning scheme, and basically the table is made up of these manifests. Okay, so it's not listing individual files, but manifests. The difference is a manifest is a group of files. And the reason it's done that way is so that way we have more reusability of these definitions. Less information is stored in these snapshot files because you're not storing data on every file. Instead, you're having data on these groups of files called manifests, which, sometimes may be organized based on your partitioning or organized in some way. But the idea is that these are groups of files. And we'll talk more. And basically, at that snapshot level, they'll have metadata on the files as a group. So not individual files, but the groups of files, each manifest. And the metadata in that snapshot file will say, okay, well, this particular manifest contains, for the partition columns, values X through Y. And basically now here we can use partition filtering. So we can sit there and say, based on our partition filters, like for any filters on partition columns, we can take a look at that metadata and say, okay, hey, this manifest represents this range of partition values, and say, okay, I don't need to scan this one. So this manifest list can just be tossed out altogether, and you can toss out as many of these manifest lists or these manifests as possible. Okay, so that's essentially the next level. So again, we went to the metadata.json, said, okay, here's the table, here's a snapshot we want to scan. Then we went to that snapshot file and said, okay, let's look through the metadata for each manifest and see which manifest we do or don't need to scan. And then the last step is you'll go to the actual individual manifests, which actually do list the individual files that make up the data and has metadata on those files, which actually includes column value ranges for every column, or depending on your settings, could be less or more columns. You don't have to have that metadata for every column. You could end up having metadata bloat for really wide tables because of that. So you can tailor that. But for any columns that you do track metadata for, it'll track it, and you can use what's called min-max filtering. So basically, if you have filters on non-partition columns, you can still use those filters to help speed up your query, because it can be like, okay, well, this particular file covers values in this column between X and Y. I'm scanning for Z, so I don't need that file. And it can then be saying, okay, I don't need to scan this file, I don't need to scan this file, I don't need to scan this file. And at the end, it's going to determine the narrowest number of files that it needs to scan to execute the query you're asking for. Okay. Now, of course, there are things that can impede this, like the way your data is sorted. Because basically, if your data isn't very clustered on the columns that you are scanning on the most, whether they are your partition columns or not, well, what's going to happen is that those ranges are going to be really wide, so its ability to actually reduce the amount of manifests or individual data files it needs to scan are going to be a lot less. So you're generally going to want to sort your data. This is where things like compaction and other types of optimizations come into play. That's going to be the main thing. So you can generally speed it up by just having sort of the data in the data files be more organized, so that way it can take advantage of that min-max filtering and that partition filtering more effectively. But that's essentially the role of the Iceberg metadata. It breaks it up into these 3 layers, so that way you reduce the amount of work, or you're not having to read things that aren't necessary if it can be avoided. Okay, which allows really well-structured data to be really, really performant when it's scanned. Okay, so basically the Iceberg format is going to allow you to have very efficient planning, and then if you have really well-structured data, meaning you sorted it, good file sizes, you're going to really maximize the performance of that data, to competitive to data warehouse type speeds. So hopefully you guys enjoyed that. My name is Alex Merced. I'm one of the hosts here at Select Star from Data Lake. Also, make sure to check out a recent episode of another podcast called Gnarly Data Waves that we did, talking about data as code. It's a new trend in data to try to apply a lot of coding principles to data, such as CI/CD and versioning. And in that episode, we talk about a particular Iceberg catalog called Dremio Arctic, and how you can use that to version at the catalog level to, give you all sorts of different benefits. I'll let you just watch that. I do a little demo in there. It's really cool. Check it out. You can check it out on your favorite podcast. Just look up Gnarly Data Waves. Have a great day and enjoy. See you there.